Hey YouTube. Today I'm going to talk about the basic Chinese volt ammeters that we get from China and use in a lot of our projects. This is a 0 to 30 volt, 0 to 10 amp volt and ammeter with built-in current shunt. This one uses its own separate supply from the measuring terminals. They can be on a common point, but the problem comes in where you're trying to do measurements, etc. So it's better to supply this thing with its own separate power supply and then have your measurement points connected to your project or whatever the case may be. So I'm going to show you guys the basics of using one of these now, and we're also going to talk about how to align it and pretty much how accurate it really is. Now, these devices are not precision devices. They're not designed to be used as a multimeter for setting up or measuring things. They're just as a guideline in your power supply so that you can pretty much gauge roughly where your voltage is set and how much current you're utilizing. So let's take a look at it down on the bench up close and personal. Hey guys. So here we have the device hooked up in a basic form. Now in actual view it doesn't flicker like this. The input is a 3-wire system due to the current. You've got your current in-out negative section, which is a bit different, but I'll get onto that later. Right now I've just got a 5-volt power rail powering the device, and I've got a variable input over here being monitored by the multimeter. So you can see we've got 2.78, 2.85, more or less close enough. If we move along, 4.71, 4.70. This power supply is not always the most stable, but you can see it does get the job done and it can be aligned. So let's take a closer look at those alignment screws, and you can then decide from there how you can go about. If you're going to align one of these, I suggest you get yourself a precision voltmeter or a decent quality multimeter. You use that to align the device in conjunction with good practice basically. So let's take a look at the device close up on the back and see how the alignment is done. Okay, so when you look at this device up close, you've got two different connections. You've got your positive and negative power rail, which you can connect to a 5-volt power rail or whatever the case may be. And you've got your positive voltage sense wire, which reads your positive voltage. Then you've got your negative output and your negative input. Negative input meaning these are the two that technically are going to connect to the terminal, and then a common positive and this are going to connect to the power supply. So when you're reading through the meter using these two wires over here. It's quite simple. The alignment of this meter is carried out by making use of the potentiometers on the back over here. There are two of them. This one over here, which is for voltage adjust, and this one over here, which is for current adjust. So you can use those two to adjust and calibrate your meter to within spec, which is quite nice. I've used these meters on multiple projects and I've never had a problem with them. Once or twice I've had ones where you know, they sort of get a digit die or digit goes loose or whatever. So what I tend to do with those is apply some flux, remove them from the plastic housing, and just either drag solder all the terminals or apply a hot air gun to it just to secure everything and get everything nice and soldered again. And by hot air gun I don't mean industrial hot air gun, I mean a proper reflow hot air gun. So yeah, they're quite handy little meters. Like I say, I've used them in multiple projects and I've never had an issue with them to date. And I quite like the dual color display. It's always quite nice to see that. So yeah, there's not much more to show about these meters. Like I say, they are basic to use. You get them in different volts amps ranges. This is a 30 volt 10 amp device, so it can read up to 30 volts on the volts display with 100 millivolts of sensitivity. If you're down on the lower voltages like 7 volts, you'll get 10 millivolts sensitivity on this, or not sensitivity but resolution. So low voltages you'll get 10 millivolts resolution, high voltages you get 100 millivolts resolution, and the amps is up to 10 amps, so in other words 9.99 amps, so you'll get 10 milliamps resolution on this meter. Fantastic meter to have. Like I say, it's only really a guideline for your projects or your power supplies, or if you may be modifying an old analog power supply to be able to have a digital function on it, this is another way you can do it. Yeah, we have one of those panels actually in a little DIY power box that I made up. This power box has got 5 and 12 volts fixed, high current. It's actually connected to that computer power supply over there, which is also used for testing motherboards, etc. And then it also has a variable LM317 with a really large heatsink on it, hooked up to the potentiometer and the terminals there, so that you can actually get your variable voltage out. At the back over there you can see the heatsink that we've got going, so it handles 1.5 amps without breaking much of a sweat. It does get warm, but it doesn't get hot. So yeah, they're quite useful displays, like I say. I may think of using one to do some modifications to some of my other power supplies. For example, these two power supplies there behind the meter are both analog needle supplies, whereas my other power supplies on my bench are digital. So that makes a whole lot of difference. I like analog movement needles, but the digital just gives you a little bit more information on hand. So yeah, it's really a nice piece of kit to have. So guys, thanks for watching, and I hope you guys enjoyed that episode, and there will be lots of more mini videos coming your way soon.